Hi guys, you asked for a video, so I'm making you a video. I'm so nice. So for section 4.1, radian and degree measure, I want to find one positive and one negative coterminal angle for each of the angle given in standard position. So for letters A and B, those are in degrees. Anytime you're working with degrees, you are going to add 360 to find a coterminal angle, as well as subtract 360 to find a coterminal angle. So if I take 225 minus 360, that gives me negative 135 degrees. 225 plus 360 gives me 585. So one positive, one negative. Same thing for negative 700, so negative 700 plus 360 is negative 340. That's still negative, I want to make it positive, so I'm going to add another 360. So that gives me 20 degrees. I can do negative 700 minus 360, and that gives me negative 1060 degrees. For my radians, I'm still adding and subtracting 360, but I'm looking at it in terms of radians. Radians for 360 is 2 pi, so I want to add and subtract 2 pi. But of course, if you're adding and subtracting fractions, you need a common denominator. 2 pi in terms of fourths is going to be 8 pi over 4. So I'm taking 1 pi over 4 plus 8 pi over 4, that gives me 9 pi over 4. And then 1 pi over 4 minus 8 pi over 4 is negative 7 pi over 4. And then for sixths, 2 pi and 6 is 12 pi over 6. So negative 5 pi over 6 plus 12 pi over 6 is 7 pi over 6. And negative 5 pi minus 12 pi is negative 17 pi over 6. All right, next up, 4.2. So 4.2, let P be a point on the unit circle that corresponds to T. Find the coordinates of P and give the exact values of the trig functions at T. So it says draw a picture, so I should probably draw a picture. So I'm going to draw my picture, and what I'm doing while I'm drawing my picture is I'm going to find my reference angle, and that's going to help me figure out my point, this piece right here. So my angle is 2 pi over 3, so I need to graph 2 pi over 3. I'm going to start by writing my pi and 2 pi. But again, I want to adjust it so it's the same denominator. So this becomes 3 pi over 3, and then 2 pi becomes 6 pi over 3. So 2 pi over 3 is going to be in this quadrant because it is before 3 pi over 3. So that right there is the 2 pi over 3. This is my reference angle. So I'm asking myself, how much further do I need to go from 2 pi over 3 to get to 3 pi over 3? And that is just pi over 3. So my reference angle is pi over 3. So from here, I'm going to use my hand trick to figure out my ordered pair. If you do not know what the hand trick is for the unit circle, I recommend searching for it on YouTube because it'll teach you how to find your coordinates for the reference angles. So pi over 3, that's going to be the index finger on my hand trick. My x-coordinate is 1/2. Y-coordinate is root 3 over 2. Now because I am in the second quadrant, that makes my x negative, y is positive. Now to write my final answer, my x-coordinate is cosine, y-coordinate is sine. So cosine is negative 1/2. I'm going to take that and flip it over, that becomes negative 2. Sine is root 3 over 2. I'm going to take that and flip it over. That becomes 2 over root 3, which I do want you to rationalize. That becomes 2 root 3 over 3. And then tangent is y over x. So I have root 3 over 2 divided by negative 1/2. My 2's are going to cancel, so that just leaves me with root 3 over negative 1 or negative root 3. I'm going to take that and flip it over. That gives me negative 1 over root 3, which we need to rationalize, and that becomes negative root 3 over 3. If you do not understand how I'm rationalizing it, you can search for rationalizing radicals as well. For letter B, I'm going to do the same thing. I'm going to graph it. So 7 pi over 6. This time I'm working in sixths. So this is 6 pi over 6 and 12 pi over 6. 7 pi over 6 is going to put me in the third quadrant because it's past 6 pi over 6. Now this right here is my reference angle, so I need to ask myself how much further past 6 pi over 6 do I need to go to get to 7 pi over 6? And that is just 1 pi over 6. Using the hand trick, my reference angle with pi over 6 is my ring finger. My ring finger is going to give me the ordered pair, root 3 over 2 and 1/2. But since I am in my third quadrant, I'm going to make both of those negative. Cosine is my x, sine is my y, tangent is y over x. So 2's cancel, negatives cancel, so that just leaves me with root 3. I feel like I did something wrong. Oh shoot, I did something wrong. Gosh darn it. Alright, let me start that over. So cosine is my x. X is negative root 3 over 2. Sine is my y, negative 1/2. Tangent is y over x, so negative 1/2 over negative root 3 over 2. 2's cancel, negatives cancel, so that leaves me with 1 over root 3, which I need to rationalize. Since sine is negative 1/2, cosecant is negative 2. Cosine is negative root 3 over 2, so secant is negative 2 over root 3, which we got to rationalize, so negative 2 root 3 over 3. And then cotangent's 1 over tangent, so I'm going to take my 1 over root 3 and flip it over, which just gives me root 3. All right, number 3 is just finding the reference angle, so I'm going to start by graphing this. So 135 is in my second quadrant. So this right here is 135 degrees, so I need to figure out how much further I need to go to get to 180. So 180 minus 135 is 45 degrees. Now your reference angle should always be between 0 and 90 because it's an acute angle. 267 is in my third quadrant. So that right there is 267 degrees. This is my reference angle, okay, always against the x-axis, never the y-axis, so don't do that. So I'm going to take 267 minus 180, which is 87 degrees. And then for 17 pi over 9, I'm going to go ahead and graph it in terms of ninths. So pi in ninths is 9 pi over 9. 2 pi in ninths is, let's see, 18 pi over 9. And 17 is a lot closer to 18 than it is to 9, so it puts me in the fourth quadrant. So that right there is a 17 pi over 9. Here's my reference angle, so I need to figure out how much further I need to go from 17 pi over 9 to 18 pi over 9, and that is pi over 9. All right, number 4, find the exact value of the following trig function. So I have 6 problems. I'm not going to do all 6 because it gets quite repetitive. So what I am going to do is I am going to do letter A, letter E, and should probably do a tangent, so I'll do letter D. So the first thing I want to do is, since I have a negative angle, I want to find the positive coterminal angle. So I'm going to start by adding 360. When I do that, that gives me 45 degrees. So 45 degrees is already my reference angle because that is on your hand trick. So 45 degrees is in the first quadrant. So my reference angle is 45 degrees. I'm going to use my reference angle to find my ordered pair. So my ordered pair at 45 degrees is going to be root 2 over 2 and root 2 over 2. Cosine is my x, sine is my y. So my final answer is just going to be that y coordinate of root 2 over 2. For letter D, again, I do have a negative angle, so I'm going to go ahead and add 360. When I do that, that gives me 240 degrees. So I'm going to go ahead and sketch out 240 so I can figure out my reference angle. 240 is going to put me in the third quadrant. So 240. My reference angle is going to be 240 minus 180, which is 60 degrees. Okay, so I'm going to use 60 degrees to get my ordered pair. My ordered pair at 60 degrees using the hand trick is 1/2, and root 3 over 2. But because I am in the third quadrant, I'm going to go ahead and make both of these negative. Now, to actually find the answer for tangent, tangent is y over x. So I have negative root 3 over 2 over negative 1/2. My 2's are going to cancel. My negatives are also going to cancel, so that leaves me with just root 3 as my final answer. All right, cosecant of 3 pi over 4. So I'm going to go ahead and graph 3 pi over 4 because, again, I want my reference angle. 3 pi over 4 is going to be over here because pi is 4 pi over 4. 2 pi is 8 pi over 4. And 3 pi over 4 is closer to 4 pi over 4. It's before 4 pi over 4. So this is the 3 pi over 4. And that makes this how much further I need to go from 3 pi over 4 to get to 4 pi over 4. And that makes my reference angle pi over 4. My ordered pair at pi over 4 is going to be root 2 over 2, root 2 over 2. And again, I'm getting these ordered pairs from the hand trick or from the unit circle. And since I am in the second quadrant, that makes my x-coordinate negative. Now, whenever I have a reciprocal function, what I want to do is I want to find the original one first. So the reciprocal of cosecant is sine. So I actually want to find sine of my angle first. Well, sine is my y-coordinate. So sine is going to be root 2 over 2. So that means for cosecant, I want to flip that over. So that becomes 2 over root 2, which we have to rationalize. That becomes 2 root 2 over 2, and then those two 2's are going to cancel. So that just leaves you with the square root of 2. For letter C, this one's secant. So the reciprocal of secant is cosine. So you would find cosine first and then take that answer and flip it over. But like I said, I'm not going to do all of them because it gets repetitive. And I think I picked the more challenging of these 6 problems to go over. Okay, right triangle trigonometry. So this one is good old SOHCAHTOA. I'm going to go ahead and write SOHCAHTOA. Please make sure you can spell SOHCAHTOA correctly, otherwise that defeats the purpose. I'm going to go ahead and label my sides. There's my theta. Straight across from theta is the opposite. Right next to is the adjacent. And of course the longest side across from the right angle is the hypotenuse. I do need to find the third side because I need all 3 sides to be able to do SOHCAHTOA. This side's actually 12. It's a Pythagorean triple. But if you did not know that, you can use the Pythagorean theorem, which is what I'm writing down right now, to be able to solve for that third side. I'm not actually going to go through the process of solving, though, because I already know it's 12. So sine is opposite over hypotenuse, so that's 12/13. And if sine is 12/13, that makes cosecant 13/12. Cosine is adjacent over hypotenuse, so 5/13, which makes secant 13/5. Tangent is opposite over adjacent, so 12/5, which makes cotangent 5/12. All right. Next up, special right triangles. So for special right triangles, you do need to memorize how your angles relate to your sides. So there's 2 special right triangles. We have 30, 60, 90, and we also have 45, 45, and 90. Now across from the 30 degrees is 1, across from 60 degrees is root 3, and across from 90 degrees is 2. You just got to memorize that. Across from 45 is 1, across from 45 is 1, across from 90 is root 2. So looking at letter A, I'm going to go ahead and start by labeling my sides. So across from my 45s are both 1s, across from my 90 degrees is root 2. Now every single time I write those numbers down, I'm also going to attach a variable, and I'm going to use A because x was already taken since we're trying to solve for x. You could really use whatever variable you want. Now if you'll notice, one of your sides actually has a numerical value. That side I'm going to circle. And the side that I circle with the expression, I'm going to use that to set up an equation. So I have 1a equals 3, so that means a equals 3. And the reason why I'm solving for a is because it allows me to solve for x and y very easily. So x was 1 times a, so x is also 3. Y is root 2 times a, so that becomes 3 times root 2, so 3 root 2. I don't know why I wrote 3. There we go. And then for the 30, 60, 90, so across from 30 degrees, if this is 30 degrees, that makes this 60 degrees. Across from 30 is 1, across from 60 is root 3, and across from 90 is 2. And again, I'm going to go ahead and attach those variables. I have one side that has a numerical value, and then that's going to help me create an equation in which I can solve for a. So a is 7. And then because I know a, I know x is root 3 times a, so that would be 7 root 3. Y is 2 times a, so that would be 14. And there you go. I'm not going to do the other two because it's the same type of problem. All right. Number 7, finding the quadrant containing theta if the given conditions are true. So this is going to 4.4. So in order to do this, it is very helpful if you draw out your quadrants. So this right here, all of my trig functions are positive in the first quadrant. This is quadrant number 1. Quadrant number 2, sine is positive, everything else is negative. Quadrant 3, tangent's positive, the other two trig functions are negative. In quadrant 4, cosine's positive, everything else is negative. Okay, you can remember that by saying all students take calculus, or my personal favorite, all students try crack, whatever helps you remember. Okay, so for letter A, I want my cosine to be greater than 0. Greater than 0 means it's positive. And I want sine to be less than 0. Less than 0 means it's negative. So cosine is positive over here and over here. Because everything's positive in the first quadrant and cosine's positive in the fourth quadrant. But I also need sine to be negative. And since everything is positive in the first quadrant, that means sine is negative in the fourth quadrant. So my answer for letter A is going to be quadrant 4. For letter B, I need tangent to be negative. So tangent is going to be negative in these two quadrants, because it's positive over here because everything's positive in quadrant 1, and it's positive in quadrant 3. And then I also need secant to be positive. So secant is not one of our trig functions. It's the reciprocal function. So I'm going to find the original one first. So secant is the reciprocal of cosine. So really what I want to look for is I want to look for when cosine is positive. And cosine is positive in this quadrant. So that is also quadrant 4. Oh boy. Hang on a second. Trying to erase this green circle. There we go. All right. So, gotta erase this green circle. All right, so this is also quadrant 4. And then for the last one, I'm going to rewrite this in terms of my original 3 trig functions, sine, cosine, or tangent. So cotangent's the reciprocal of tangent. Cosecant is the reciprocal of sine. So I want tangent to be positive and sine to be negative. Tangent is positive in these two quadrants, and sine is going to be negative in the third quadrant because sine is positive in the first quadrant because everything's positive in the first quadrant. So my answer for letter C is going to be quadrant 3. All right, last questions. So again, I'm just going to do one of them because, if you can do one, you can do the other one. So I'm going to do, let's see, which one's the more complicated of the two? I'm going to do letter B. So at letter B, I have cosine is negative 1/3, so I know cosine's negative. Sine is less than 0, so sine is also negative. So I'm going to use that to draw a triangle in the quadrant that meets those stipulations. So cosine is going to be negative in these two quadrants, but also with a negative sign, that is going to be this quadrant right here, my third quadrant. And I'm using the same idea that I had with this one, the ASTC. to figure out the quadrant that I'm in. So now I'm in quadrant 3. I'm going to go ahead and draw a triangle. So I went straight out into my quadrant, straight to the x-axis, always the x-axis, never the y-axis. And your theta is your reference angle, so that's always going to be resting against the x-axis. Now I'm going to think back to SOHCAHTOA. So SOHCAHTOA, I have cosine is adjacent over hypotenuse. So that means my adjacent side is 1 and my hypotenuse is 3. So 1 and 3. And because it is negative, that means one of those values is negative, and your hypotenuse can never be negative, so I'm going to go ahead and make that 1 negative. And it does make sense that the 1 is negative because I am in the third quadrant. And in my third quadrant, my x is negative, and so is my y. Speaking of my y, I need to figure out what the heck that is. So I'm going to use the Pythagorean theorem. So I got a squared plus b squared equals c squared. So 1 plus b squared equals 9. Subtract 1 from both sides, you get b squared equals 8. So b equals the square root of 8. Technically, I should simplify the square root of 8. It's 2 root 2 if you really want to know, but I'm feeling a smidge lazy, so I'm not going to do that. So my square root of 8, again, I'm going to go ahead and make that negative because, you know, you're in that third quadrant. And now I'm going to do SOHCAHTOA to fill in the rest. I already had that cosine is negative 1/3, so that means secant is negative 3. That was given to me. It's right here. And then for sine is opposite over hypotenuse, so my opposite side is negative root 3. Just kidding, that's an 8, not a 3. Negative root 8 over 3, which makes cosecant negative 3 over root 8, which technically you should rationalize, but again, don't feel like it. Tangent is opposite over adjacent, so my opposite side is negative root 8 over negative 1, which is just root 8. And then cotangent is going to be the reciprocal of that, so I'm going to flip that over, so I have 1 over root 8, which again, I should probably rationalize, but I'm not going to. All right, so that covers a vast majority of the problems that you are going to see on your 4.1 through 4.4 test. I hope this video helps you out while you are preparing for your upcoming test. Adios!